Romeo from GuardKnox Cyber Technologies. We also have with us Maurice Swinton from the National Center for Manufacturing Sciences. But Joe, I got some questions here that were sent to me. Tell us a little bit about GuardKnox, because I'm not familiar with your company other than you mentioned before we started that you're in the Plymouth area. And so I'm sure there's more to it than that. So tell us all about it.
Yeah, sure. So actually, GuardKnox has a brick and mortar in Livonia, Michigan. So right in the corridor amongst all the OEMs and the tier ones in the automotive industry. GuardKnox was founded in 2016 by some folks with some deep background in defense aviation. And they kind of realized that they have this really deep experience in advanced networking, computing, and cybersecurity. And that would port over very well to the automotive industry, which in 2015-16 timeframe, everybody was talking more about autonomy than connectivity and electric, which is kind of where everything is at now, more connectivity and electric. They have so much experience directly applicable to that. And so they said, hey, let's start up a company and we could probably help a lot of folks. And so what we're doing kind of to accelerate cybersecurity and other advanced technologies for the automotive background is working with tier ones and OEMs in the automotive space and also the government to just to kind of present and propose advanced vehicle electronic architectures. Now, this is, when I say architectures, I'm talking about the computers and the controllers that basically are responsible for all the functionality of our vehicles these days, the networks that connect them, and also allow them to connect to the outside world. And you need not only the functionality, but you need to cover the safety and the security and the cybersecurity of those systems. And that's what GuardKnox is doing with OEMs, tiers, and the government.
Okay. The latest technology brief from the National Center for Manufacturing Sciences in Ann Arbor is called Accelerating Cybersecurity for Software-Defined Vehicles. Now, that focuses on a recent collaboration between NCMS, Synergistic, and GuardKnox. So what was the primary purpose of this project? And tell us a little bit about GuardKnox's role as well as that of Synergistics and NCMS.
Yeah, sure. The purpose of the project was basically to perform a feasibility study on all the cutting edge industry best practices in the automotive industry for these advanced EE architectures I was talking about earlier, the electrical architectures for vehicles, but also as it applied to cybersecurity and within the context of something called MOSA, which is Modular Open Systems Architecture, and cyber survivability, which are an attribute list based on some NIST standards that also are used and leveraged by the government for their vehicles and within industry. So that was kind of the purpose of the project, was to do a feasibility study, create a report of best practices and ideas to educate on those topics, and then see how they could be best leveraged as these higher connected software-defined vehicles come down the pike. Synergistic was really the prime contractor. They were the interface between GuardKnox as a subcontractor and NCMS, who kind of managed the project. They were the project managers. And together we performed the study and created the report.
And Synergistics is a like a where-based what? What are they and what do they do?
They are primarily a prime contractor, primarily for government contracts where they handle program management. They're located nearby. They're not on the call today. The CEO couldn't make it, but they're located just upriver or downriver of Detroit. And so they partner with a lot of smaller companies like us. And Synergistic themselves is a disabled veteran-owned business. So obviously he's a great leverage point for government contracts. And so he was in on the project management side.
Okay.
Let me ask you sort of a two-part question. I'm not even that familiar with the definition for software-defined vehicles. Why don't we start with that? Why don't you define that?
Sure. So these days, vehicles are really no longer about horsepower and torque and functionality and 0 to 60 and G's around a corner. Yeah, if you pick up Motor Trend and Car and Driver, they still do those tests, and guys like me still love them. But the overwhelming majority of operators have now become the focus of the vehicle. And the way we've been able to make them the focus is because of all the software that is responsible for running these vehicles. These days, there's very little differentiation among vehicles when it comes down to hardware. They're all basically using the same silicon chips, the same computers, the same cables, the same networks, and a lot of the same rims and tires and seats and all those systems. But the software, the connectivity, the applications that you see on your infotainment system, the safety and the cybersecurity, all software-based, those are the real delineators for modern day vehicles. And so vehicles are literally becoming defined more by software, like a desktop computer, than the functional hardware.
Interesting.
I was just at Mitsubishi this morning. I run looking at their new glass dashboard, and I asked the same questions of them. They got the components from different places, but the software, that's their baby. Nobody does the software but them. And so along with that, now that we've defined that, so how did this collaboration contribute to a new approach for cybersecurity for what you just said was software-defined vehicles?
Yeah, well, we did a lot of research. We pulled together tons of data and information. And a lot of the folks involved in the feasibility study, myself included, are 25 plus year veterans of the auto industry, having worked at the big three, the tiers. So we pulled together a lot of research on what's new and current coming from existing architecture. So to give you an example, up until 10 years ago, 15 years ago, there were 30 or 40 controllers in a vehicle. Now there are upwards of 150 controllers. By controllers, I mean, let's just think of them as embedded microprocessors, microcontrollers, computers. Those architectures are going toward more advanced computers, just a handful called zonal architectures, but there are a lot of steps along the way. So that collaboration identified and defined a lot of those technologies. And then we looked at a potential conceptual architecture for a new modern vehicle. We performed a risk analysis on that vehicle, something called a TARA, which is a threat and risk analysis. It's kind of a buzzword in the industry, and it's exactly what it sounds like. You look at the potential cyber threats that could face your system, and then you look at mitigation of those threats in the form of cybersecurity software stacks and methodologies. And ultimately, we pulled that all together and we proposed a reference design that uses a lot of the best practices, not only for the architecture, but also for the cybersecurity to provide the functionality of these new architectures and protect it.
Okay, so what do you think will be some of the near-term developments in cybersecurity for these software-defined vehicles coming up in the next few years?
Well, so we've made a lot of headway. I've been trying to sell cybersecurity into the auto industry from a tier one position going on about 12 years now. And what's very interesting is most OEMs don't want to necessarily buy cybersecurity. They want to say the components that you sell us, including your computers, need to have cybersecurity built in. You need to have that just to come to the table and talk to us. And everybody understands that now. But there are two key areas that are under the microscope and being heavily developed. And they're showing a lot of promise. Number one is the whole AI machine learning thing that everybody's talking about. So to answer your question directly, one of the things that needs to happen in the next 4 to 5 years is we need to see the promise of AI actually delivered. Right now, there's a lot of promise there, but AI approaches are still very hard to scale. They're allowing like hidden backdoors to be hidden into the software. They're leading to a lot of false positives and missed negatives. And in general, they can't be formally verified. But none of that means they shouldn't be directed and developed further. It's just that we need to see that development really progress to where we think it can go without incurring some of the potential negative aspects that everybody's talking about, especially the last couple of months with AI. And the other area is the protocols, right? There's a network that vehicle computers talk on. It's called CAN, Controller Access Network. It was developed by Bosch nearly 20 years ago. Everybody uses it, but it's kind of old and antiquated. It's being replaced by something like Ethernet, which is a lot higher speed, but even that will have vulnerabilities. And to give you an example, just this week, a story popped where some very crafty hackers were pulling headlights off of advanced modern vehicles, 2 to 3 year old vehicles. They're pulling the headlights off. They're tapping into the CAN network through the headlight and sending a command, starting the car and unlocking the car. And this is a hack that's even more pervasive and easier to do than what Smith and Vlasic did back when they hacked the Jeep and brought this to the forefront of everybody's knowledge with FCA at the time. This is even worse. This is a more fundamental hack where they literally were able to walk up to a car, take off the headlight, and start it and break into it. So that physical protocol and others need to be developed further, but also protected further.
Let's we're running out of time. Let's bring in Maurice Swinton from the National Center for Manufacturing Sciences. You can unmute. Anyway, the question I want to ask is, let me ask the second question because we've kind of covered the first already. What particular attributes does the NCMS bring to the digital enterprise environment, and how does it support or enhance the capabilities of your resource partners and clients?
Thank you, Mike. I appreciate that question. And from an NCMS perspective, and Joe, thank you too for a lot of the information you provided. That's right up the alley where NCMS is also striving to ensure that we have those types of protections on any systems that we provide to our resource partners and clients. One of the systems that we utilize quite a bit is called the Digital Proving Ground, or DPG. And that DPG runs in the cloud. It's on an AWS platform. It allows different clients to collaborate in a single workspace. And what we've done, we've built all types of security around that particular environment that allows those different companies to come in, work on a specific project for the government, create their portions of the project, turn it over to the government, and then their data is then concealed within different compartments. So that data still belongs to the company, or if it's part of the contract, it belongs to the government, however the contract is structured. Another thing that the NCMS is doing right now, Mike, is that we're standing up our own cloud, because that cloud is a cloud that's run under the Siemens umbrella, who is one of our resource partners. We've done a lot of work with them, but NCMS is standing up its own AWS cloud where we own, control everything in the cloud. We're building that platform, or that cloud platform, utilizing one of the DoD's highest levels of security, which is Impact Level 5, or IL5, which would contain all of the security requirements that DoD is already levied upon some of its larger primes that work with the DoD to develop different support, like maintenance and sustainment for the DoD. But we are, like I said, we are standing that cloud up now. That cloud will have an ATO, an authority to operate, will be super secure. We're also putting the data in what's known as containers, so that the information is going to be even more secure in that particular environment. But that DPG is one of the, I would say, one of the resources that NCMS brings to bear to support its clients right now, its resource partners. The DPG's been up and running probably for the past couple of years. Software licenses, the clients don't have to worry about that. NCMS provides those particular software licenses. There's a ton of different manufacturing software in the DPG that's at the availability of all of the end users. So they get to use that software for a fraction of the cost if they were to go out and try to get those licenses themselves.
All right. Well, we're running out of time. Folks want to reach out to you, Joe, and you, Maurice. So give that website address so they can do so.
Sure.
Absolutely.
Go ahead, Maurice.
Oh, I'm sorry, Joe. If you want to reach out to the NCMS, we're at www.ncms.org.
Yep. And GuardKnox is www.guardknox.com. That's spelled GuardKnox.com.